I want to talk about running a Xelis node on Raspberry Pis. Um, it's pretty much the same setup process as normal, with one caveat if you're using an older Pi. Older Pis don't have quite enough RAM to build. And the way you get around this is you just increase the swap file size. Today I'm using a 3B, and this is one of the best selling pies of all time. So I think it's a pretty safe assumption that a lot of people who may be trying to run a Zealous node might have this one. Um, all of these steps, of course, probably don't apply to you if you're running a newer Pi or just a Pi with more than, as you can see, like a gig of memory here. Um, but I have actually tried running this on an even older Pi than a 3B, and there's some extra hoops you have to run through, and the performance isn't all that great. Um, but on a 3B at least, you can get the node running pretty well, and it's not that hard. There's just this one extra step to increase the swap. So, that said, I think first let's do free H. You'll see that the swap by default is a half gig, 500. It says here 511 megabytes. First thing we're going to do is change that to 2 gigs. Now, I don't know exactly. I haven't like tried to fine tune what you know the minimum swap file size is, but 2 gigs works, so that's what I've gone with. Um, we can just change this to 2048 and save and then exit. After we set the swap file size, if we do free-h, you'll see it still says 511, which is the old value. What we now need to do is kind of stop the swap file and set it up and restart it. So we can do that by typing in sudo dphys swap file swap off, and same thing but setup, and then same thing but swap on. And now we can see it's returning 1.9 gigs. So from here, we can proceed like normal, install Rust, install Git clone the repository, and then build the repository. I'm not going to show that because I've shown that before. I'll just see you back here with all that done. All right, so here I've got the node running. On the left, you can see htop showing how much memory is being used, how much of the CPU is being used. And on the right, I've got the actual node. So I just wanted to highlight that, the core of your, Raspberry Pi is not going to really be used all that much. Memory, maybe a little bit. Swap, really not so much because, of course, we had to make it 2 gigs to build, although actually mine technically decreased itself as it built. But that's only because I'm using such a small SD card. And I think it got into something where it's not allowed to set a certain amount of the free available space as swap. Um, but anyway, I just wanted to highlight that some of the times we're seeing the average seems to be about 50 milliseconds or less. However, occasionally you get a transaction on some blocks and it takes a little bit longer. So like this one right here, it's like 121. And let's see, this one's 122 here. This one right here had 6 transactions and it took 739 milliseconds, which is a pretty long time. Um, when I run a node on my laptop, I usually see times less than, maybe 5 milliseconds. And that's a computer with a pretty decent processor. I wouldn't expect as much from the Raspberry Pi, so all things considered, 50 milliseconds per empty block is fine. Um, but with these bigger blocks, you see it can take a little bit longer. Still, even though the 739 is a really long time for it to process that transaction, and there could be blocks with even bigger transactions than these 6. I did check the Explorer when I saw this hit, and it was a pool paying out a whole bunch of its miners um, in transactions of I think only 25 transfers each, and that's nowhere near the max size. Um, so yeah, under very, the absolute worst conditions, you can expect to maybe see worse than that, but none of that is really enough to knock this thing out of sync. Um, it's not ideal, but you're also running a node on a Raspberry Pi, so you're kind of expecting that you're not going to get the best performance out there. Yeah, so all things considered, looking at how little of the CPU is used, um, you know, this uptime is only about 9 hours, so I think I've let it go for a few days before. With this kind of spec, no CPU usage almost, and very little of the memory being used. It could pretty easily probably go weeks and weeks without you needing to really check on it. Um, yeah, so this is what a 3B looks like. I think next I'm going to try and see if I can show you what a 1B looks like. All right, so here we have the original Raspberry Pi B revision 2.0, and I've run the pinout command so you can see that. That's in the pinout command's in the left window, and in the right window we've got the node itself. So I'm going to run htop so you can see the usage. The CPU will spike up to about 30%, I think, is the highest I've seen it go. That's usually every time a new block goes in. Actually, there it just went to 60 with two blocks in quick succession. Memory is not so bad, all things considered. Um, and the real, you know, downside to this is, as you can see, we're getting, like 600 sometimes. Actually, right here, this one's 2.8 seconds. We're getting very slow times when new blocks need to get processed. So empty blocks are, way, way slower than we saw in the 3B. Um, and any block with a transaction is just monumentally slow. I think the worst I've seen when I did some testing with this Raspberry Pi was maybe a week ago. I think the worst I saw was 19 seconds. And that was like the, worst case scenario where a pool pays out 255 miners all at once in one transaction, creating, just about the heaviest blocks you typically see. And although that's, rare for a pool to do that, you're guaranteed to have that happen multiple times a day. There's something like 5,000 blocks per day. So um, that pool in particular does that, a few times a day. So it's only a matter of time if you run the node for any significant amount of time, you're going to see those 19 seconds. And that reason alone, I would suggest you maybe just don't do this. Don't run a Xelis node on a Raspberry Pi this old, but you technically can. But yeah, you really shouldn't. You should retire your Raspberry Pi ones. Um, Something to note about this is when I first got this, I did actually try and build the dev branch of the node, which right now is using a different or has the option to use a different database scheme, and that would use less space. And so that was my thinking was, well, I'll build that version, and the database will be a lot smaller on file. I actually couldn't on this Raspberry Pi. The RocksDB was just too difficult to build, and I tried the trick where I increased the swap file size. Actually, if you look over here, you'll see I have a 4 gigs swap file size, which was larger than the default maximum, which was I think 2 gigs. So I actually had to jump through extra hurdles to get it even bigger, and it still couldn't build. So that being said, it might be completely impossible in the future to build a a node on a Pi this old. The only way I was able to get this running is that I just didn't build the dev branch. I built the master branch, which hasn't implemented RocksDB yet. But if you're watching this in the future, and we are past 1.17, we're in 1.18 or something later, that just might not be an option at all. So this might be completely academic. But yeah, theoretically, right now, you can run a Xelis node on hardware this old. And by this old, I mean this is from uh, either 2012 or 2013. So it's about 12 or 13 years old at this point. Um, yeah, you theoretically can. You probably shouldn't. Um, and you might not be able to in the future. But the point being that the node is pretty low spec. You know, you can see over here what it's using. So you can get it running on most stuff. Um, and Raspberry Pis make great options. Just maybe don't go quite as old as the original.